like a new house back then costed $25,000, and now you can put like 1 zero at least, maybe 2 zeros, depending on which area you're at. And also we can see that very curiously in 1971 the income inequality became like it really started to become a bigger problem. And here we can also see that in 1971 the green line is the share of the wealth of the top 0.1%, and the red line is the bottom 90%. So we can see that until the 1970, those were like diverging, right? Like the top 1% were like becoming like having less of a share, and the bottom got more of a share. But then, curiously, 1971, that reversed, and now the lines are starting to cross again. In this chart, you can see that like the circles is like, okay, we got an emergence of populism when those cross, which makes sense because people get the sense of inequality, the sense of like the banking system, the government is not there to help us. They're just in for themselves. Yes, and now CBDCs are a step too far. So I mean, 1971, the gold standard got removed in America officially, so they were able to print money as they wanted, and they did. Like, you can really see the exponential curve of government debt after removal of the gold standard. And now we have this, the latest invention from spearheaded by the Boston Fed in Massachusetts together with the MIT digital currency initiative. It's called Project Hamilton, very aptly named after Alexander Hamilton, also after Margaret Hamilton, which brought us to the moon, which might be a reference to the "to the moon" meme in Bitcoin. So, at least they know their verbiage, their naming. And yeah, so what is this thing? What is the thing? What is a CBDC? And according to that paper, right, it's open. You can you just Google open CBDC. So it is open. It's open source. Members of the public who want to digitally store funds and make payments must open accounts with financial institutions. So this is how it's working right now, right? You have access to your banking. You have access to, that's where you can make payments. You can use credit cards through the financial institutions and so forth. And that's right on page number 2 on the white paper. Now a CBDC could be designed to offer a similar functionality to cash. So that of course is a very interesting proposition, because replace bank accounts and cash, that seems like a monumental task. But from what we can see, they are really serious. They are not joking. We can see that here. So this is a graph, and it shows the system running, right? So of course it's a prototype, but this is not this is a test, obviously. They are just setting up the system and to make transactions on the system as a test. However, we can see that the throughput here is really, really big. You can see the transactions per second in millions. So 10 to the power of 6 means millions. So we got roughly 1.7 million transactions per second on 32 logical shards, which means 32 computers, right? So, and spoiler, the Federal Reserve has money for more than 32 servers. So they will be able to handle basically any number of transactions they want. Also, since they're centralized, right? They don't have these scalability. They don't really have any scalability problems. And we can also see that there's a linear trend, right? So if you can imagine that if you double the number of logical shards, they would be able to process twice the amount of transactions per second. So yeah, and just as a comparison, 1.7 million transactions per second. That's like kind of hard to wrap your mind around. During peak times, like when it really, really gets busy on Visa, the Visa network, which is during Christmas, right? Everybody does their last minute shopping. Everyone tries to get their stuff on Amazon or whatever. They're processing around 40,000 transactions per second. So you can see that this system is like way, way, way above what Visa can handle. So yeah, it is really, like engineering-wise, it is an incredibly beautiful system. Like they really did a good job. But like civilization-wise, it's really scary because if you have like one set of servers, like in this case 32, but you know that can increase, then and all of like the entire money is running on those, it really gets problematic. And you can also see like this turquoise, like light blue line, and that is another how do you call it? Another like another architecture of this system, and it's called the atomizer. And I kept that in there because we can really see how if you have 8 servers, then it has some throughput, but if you add more servers to the atomizer, it actually gets slower. And that is like this this big scalability debate in crypto. Like, is this a scalable system? Is Bitcoin scalable? And if we were to design it like the atomizer, then no, it is not scalable because it gets slower if you add more resources. Yes, and they make nice charts, and the system really isn't that complicated. Like, it's kind of interesting that in order to process every transaction on the planet, they just need a few boxes apparently. But yeah, we can also see the verbiage, like the terms they use. So, a user connects to sentinels, and sentinel is maybe a bit of an obscure word, but it's something you would use in a prison. Watchtower, maybe a little bit more obvious. Also a term you almost exclusively use in prison. And yeah, so a user sends transactions to a sentinel, and then they can observe the state of their transaction using a watchtower. Of course, then the question is, who is watching who here? If you read the white paper, they're very big on privacy, because this is not a public blockchain, right? Like, nobody has access to the transaction data other than the Federal Reserve. And they say they are like very clear that they are going to delete all the transaction data after they processed it. And of course, they will absolutely do that. Yeah, however, this one is the unscalable version. So with this one, at some point, if you add more resources, it gets slower. And that is because of this thing called the atomizer. Like, you can see it on the top left, atomizer. And basically, this is one central point. And atomizer basically means it orders all the transactions in atomic steps. I'm not sure if maybe atomizer is also a reference to, I don't know, like maybe a Manhattan Project. But yeah, so the problem there is that ordering transactions is very unscalable. And at some point, you hit these walls. So what they did instead, they have this system. And this is a crazy scalable system. So this can really handle a lot of stuff. And you can see it's even simpler, right? It has fewer parts. And you can see a number go up in the number of transactions quite a bit. So I'm not going to explain how that works, but the curious thing is that this system has been proposed by Amaury Séchet, who, like, maybe we need to open the door to let people in at some point, who has been proposing that for Bitcoin for almost 5 years now already. And unfortunately, we got a little distracted with other things like, NFTs and number go up and so forth. Ah, there he is, the speak of the devil. And yes. Yeah, and this is a very scalable system. Where was I? Oh yeah, and Amaury has been proposing that for Bitcoin, because it turns out that the Federal Reserve will use the same transaction structure as Bitcoin. Like, they will use the same input mechanism, the same output mechanism, because for some reason, I don't know why, Satoshi discovered a really scalable thing, right? Like, the coin mechanism, very different from the account model. we'll hear more about that in later talks. All right, so what is this really? So I saw this picture in Prague, like this is around the corner here. It's a panopticon. I mean, this one is just an optometrician, but for some reason they picked the name panopticon. But this is the actual thing that they're building. It's a system where everything is running through, like this is a prison design, where basically each prisoner is can be observed from the center. It's called panopticon, pan meaning like everything in Greek or something, and opticon like seeing. Yeah. So they want to observe everything. They want to have a view of every transaction on the network, not on the network, on the planet. And the question is there no way out? But I'm here to tell you there is. And of course, we could go the political road, but as Cody Wilson said, politics is fake and gay. So we can't it's very, very energy intensive. It takes a long time to move. So instead, let us just build the future we want. So we have it. We have an alternative. It actually came way before CBDCs. I mean, they've been talking about that, but Bitcoin really is the counterbalance to that thing, a peer-to-peer electronic cash system. However, Bitcoin, the biggest chain right now, it has issues. So this is the memory pool over the last few years. And every time you have these peaks, it basically means your transactions take forever to confirm. Like, it basically means unless you're really good, unless you're really technical, you'll have big issues using the system because there's a limited amount of throughput. So on Bitcoin right now, it's roughly 4 to 7 transactions per second, and that is no bueno. However, yeah, I mean, it's not a solution. We got 10 minutes of confirmation time, sometimes hours, sometimes weeks. Often it's expensive, $1 plus of transaction fees. Confirmations can take forever. Also, we got this fancy thing called replaced by fee, which was removed when Bitcoin Cash launched. And that makes this thing called zeroconf, which basically means you just accept a transaction without it getting confirmed by miners. That makes it completely impossible because anyone can just double spend transactions as they wish, unless they're confirmed. So the solution is Coinbase, right? A very scalable system to process transactions. Like you can send money between Coinbase, like they have very relatively low fees, and they just handle that in their own database. But of course, the problem is that if you go back to the white paper, actually the goal was without going through a financial institution. So something where you don't need something like Coinbase, where you can send transactions directly from one party to another. And we got so these are the projects that I think are actually interesting. So we got Lotus. I think Shama isn't here yet. Also make sure to check the door if more people are coming. Lotus has this interesting mechanism that they're pseudo-stable. So Bitcoin is very volatile. Lotus tries to be a bit more stable. Just like eCash, it also tries to be extremely scalable. And both on eCash and Lotus, we can get decent privacy through Stamp, which kind of atomizes transactions. So you don't. So chain analysis will get much harder. Monero, also very, very interesting project. They are not stable, but they have this tail emission where just coins keep going, which I think should also stabilize the price a little bit because coins just keep going, and you can keep the network alive without having to have very high fees at some point. The problem with Monero is that it is not very scalable. So we have the issue that the more transactions are made, the slower every transaction gets, right? Because there's no transaction outset. At UTXO said there's just a transaction outset, but However, Monero has excellent privacy, right? If you move coins on Monero, it is very, very hard to track compared to anything else. Yeah, and Zcash, I'm also a big fan, but we got nobody from Zcash here. Maybe the next electronic cash conference. Suku, if you're out there, if you're listening, I think I already sent you a message anyway. Why are you not reading my DMs? So. Yeah, eCash. So we got some great news. We got Avalanche. It says coming soon, but apparently I've talked to the developers. There was some big issue with it's called peer discovery. Apparently that's like a almost like an epistemological problem, but they were able to solve it. And Avalanche will solve this, will solve multiple problems. So first of all, I mean, you can see them all down there. So we got 51% attacks that will be prevented through staking, through like the Avalanche consensus mechanism. Then in the coming weeks, months, we'll get one block finality, which means that after one confirmation, there will be no reorgs, right? Like you won't be able to like undo the chain, right? You won't be able to go back in time. Then, you know, soon in the future, we will get real-time transaction processing, which means transactions are finalized within a few seconds, right? Like we don't have to wait at the merchant to be like, okay, is this done? Is this not done? Kevin Monahan made like this story where like they went to a merchant and like a restaurant, and they're like, do you accept crypto? And they were like, oh, let me check. And they would come back, yeah, we do accept Bitcoin. And they're like, okay, let's make the payment now, because like we will get the confirmation once we're finished eating. But of course, that is terrible user experience. That is absolutely unacceptable. I think even gold bartering is better than that. But yeah. And we got a few other things, like I'm excited about subnets, because it'll allow us to try new transaction formats. It'll allow us to have a privacy chain, and a few other things. All right. One thing I'm also very excited about, and we had that since 2008, e-tokens. We had those initially on Bitcoin Cash. They were called SLP tokens, but I think e-tokens is a much better branding. I think the general theme of just taking a word and just putting E in front of it, and you know that's the brand. I think that kind of works for eCash. So yeah, I'm trying to develop a new language for scripts, and maybe we just call it eScript. Yeah, and the cool thing about e-tokens is that you can make your own fiat. You can just be like, okay, you know, let me issue some tokens. Let me be the bank. And the good thing is, like, unless you do some like security stuff, like it's legal. You can do that. There's no like, you know, you won't go to jail unless you do things that are illegal. So for example, we got the Grumpy token on eCash, which, I mean, it's a joke, but like it shows the idea. It's like, hey, you can establish a currency, or like you can make your own currency this way. Yeah, SLP, very, very cool, like very, very simple. The S in SLP stands for simple, so it's Simple Ledger Protocol. And you can see here, so this is from the spec. Really, all you do is you dump a bunch of bytes into the first output of a transaction. So this op return is just a data field. You put in like the header, you put the transaction type. In this case, this is a genesis, so it creates a new token. You put the ticker, name, document URL, document hash, the number of decimal places, and whether you want to have a mint baton. So if you want to be able to mint new tokens, which would be the case for a stablecoin, and the initial mint quantity. And once you put that in there, it'll get indexed. Like people will accept that as a token that exists on the network, and you're done. Like it's a really, really simple protocol. Yeah, that's why it's called Simple Ledger Protocol. And we can even do really cool things. So this is BUX, Badger Universal Token. And what it allows you is so you can see the P in front of the inputs, and that means that it's a smart contract, so a script. And this one is a self-minting token. So this is a stable coin that you can mint yourself. I mean, you have to buy an access token, but yeah, and that's what keeps it stable. You can then later burn the token again to get the money back that you bought the access token from. And I think this is a great example of this, like, you know, make your own fiat, because this token is actually stable. It is used in commerce. Hopefully Vin will talk about that a little bit. And yeah, and it's just a great application of eCash. How much time do I have left? 5 minutes. Okay, perfect. However, there's one issue with SLP. It is not highly scalable, right? So this architecture that I said was incredibly highly scalable. So this is from the Project Hamilton white paper. it does not work for SLP because SLP has this like transactions that are invalid are still part of the blockchain. So you can't scale it using this mechanism. So once there's too many SLP transactions, the indexes just can't keep up, and at some point they'll get desynced basically. So SLP will work very well for the foreseeable future, like maybe thousands of transactions per second. Which honestly, like if we get to that level, I think we're good. But if we want to go beyond, then we need a scalable token protocol. So for that, I proposed actually like almost 3 years ago a Mitra. It was named differently before, but that name was overused. And basically what we do there is we do a proof by induction. So we got this, like I call it preamble. It's the first script in a transaction. And basically we prove, okay, if the previous transactions have the same verify script, you can see that here. So you see the verify script. So the verify script checks if the previous transactions also have the verify script. Therefore you get this induction thing, a bit mathematical. And if you then just check these few things that hold, so like the inputs are greater or equal than the outputs, that the input has the verify script, or that is the genesis because we have to have the base case for the induction, then this transaction is valid. And what you can do is you have minor and first tokens, and these are scalable. We can use them in the 2PC, like this scalable architecture. Yes, but this is great, Tobias. Every project on the planet has been talking about the great things that are about to come on their blockchain. So where have we been? Just a quick run through. So the GNC has funded the e-token DEX. It's still underway, but it's something that has been, it's using IPFS, a very like it's one of those things that you like everybody uses it, but nobody really acknowledges it. So shout out to IPFS. I met one guy who is working on that, and like great work. Also, now just recently we got the eCash Block Explorer funded through the GNC on eCash, and it's really beautiful. So we got the explorer.e.cash. So whoever designed that, shout out, like really good work. And it looks good, right? Like looks like a fancy block explorer. Something I actually prefer using that one than the one I wrote because it looks better, which is always a good indicator. Then we got the pay button, and so the pay button will allow online commerce much better. And we actually had that issue. So it's a little bit ironic that for this own conference we weren't able to accept eCash, but that was because it wasn't part of coin payments, and we didn't want any kind of like weird attacks. So we really need these projects that are like building these systems for easy transaction processing. Also got Chronic. By the way, Alita Yin, maybe she's in the audience. She designed the logo for Chronic. It's an indexer. So that's her address. If you guys want to send some eCash there, yeah, feel free to do that. But I have to step further, so maybe you remember the QR code. Yes, and what is an indexer? So Anthony Seegers, he might be in the online chat. So he's like, oh, there's already been a ton of indexers. Like there's the list. SLPDB is probably like the most used for SLP. But what Chronic does, it builds the indexer directly into the node itself. So that makes it like it solves a bunch of problems. And Anthony goes into the problems like state, like also in programming, state is a bit of an issue, not just in politics. And we're making progress, right? Like things are getting done on that front. And you can already use it, right? Like this is the step where we're integrating it, but we already get like a version which is not integrated and works just the same way. Oh yeah, this was the pay button. I reversed the slide. So this is some pay button work, but yeah, this doesn't work. So last slide, I think they may take our lives, but they never take our freedom because we are building the tools to stay free. And yeah. That's the Electronic Cash Conference. Welcome everyone. Hope you guys have a great time.